I'm going to actually introduce these guys briefly and then have them talk a little bit about what their experience have been with designing and running pipelines. So first from Google, and also of formerly other places, we have Narayan Desai. Need the mic. Yep.
Hi, so I manage the SRE team responsible for cloud data flow and data proc at Google. So this is maybe a little different from the experience that many pipeline folks have, because we're responsible for running pipelines on other people's behalf when we didn't write the code. And so that's a slightly different angle than usual. Prior to being at Google, I actually spent 5 years working on bioinformatics pipelines, and so we were responsible for processing large quantities of metagenomics data. So I've sort of got experiences on both ends.
Cool. And we also have Matthew Flaming from New Relic.
So I'm currently VP of Site Reliability at New Relic. Previously at New Relic, I was very involved in designing our data infrastructure. So at New Relic, we accept quite a lot of incoming data, more than 1.5 billion data points a minute. And we use pipeline systems based on Kafka very heavily throughout our architecture. Some of those hot pipelines are more than 15 million messages a second. And the design and rollout of those pipelines was a central focus of mine and teams I was working with over the past few years.
And next we've got Theo Schlossnagle, and you guys all know a little bit about his system design if you were at his opening plenary yesterday. Take it away, Theo.
Yeah, so I'm the founder of Circonus. Before that, did about 15 years of hard time in consulting around data analytics pipelines and large flow for ad tech. Actually, the architecture that we have is actually highly similar to the New Relic architecture. So millions of events per second, and regrettably, if you have outages, you don't get to forget about what happened while you were down. You have to catch up.
And then our speaker from the previous session, we've got Rita Sodt from Google. He works on a completely different set of pipelines from Narayan.
Yeah, so I worked on the Google Analytics pipeline. And so this is just, the back end is in charge of processing many like web traffic hits. And then, and before Google, I actually worked in scientific computing at a university, modeling brain tumor growth, and that was a pipeline as well, my first pipeline.
So I think we've got a pretty great breadth of experience here. So on to the questions. So first off, I'm going to take audience questions at the end, but first we've got a bunch of sort of prepared topics that we're going to go through first. So if you think of questions, do make a note of them or hold them in your brain somehow, and we will have some time at the end. Okay, so a lot of the business value of SRE does come from early design consultations. So with respect to pipelines, how do you approach this? So business requirements, properties of the data, how do these things affect the way that you design your pipelines? Who would like to start?
So at New Relic, we have a centralized team that runs our Kafka infrastructure, which is the basis of our data pipelines. And we also have a group of architects. And these folks tend to get fairly involved in the design process as we're building out new pipeline systems. So some of the key topics that are discussed were ones that Laura, you just mentioned, around like what degree of case safety do we need? What is the data volume that's going to go through the pipeline? Things like that. Other points that tend to be important considerations are, number one, what is the shape of the data going through the pipeline? Are these going to be large messages or small messages? In general, we try and steer people towards lots of small messages rather than large messages. They're healthier for the pipeline overall. What's the amount of data retention that we generally need in the pipeline? And workload distribution ends up being a pretty significant concern for us as well. From a workload distribution perspective, random distribution of messages and workload across the consumers of a pipeline tends to lead to the most even distribution. On the other hand, so imagine you have a pipeline where user information is passing through. If you, hash those users and segment them out by pipeline consumer, you get very high cache efficiency, and you limit the blast radius of a failure in a single part of the pipeline. On the other hand, you can get very lumpy workloads and problematic distribution if you have, for example, lots more hits in one hash key than in another. So again, workload distribution, shape of the data, I think are key parts.
Interestingly enough, many of those considerations are pretty similar to your serving systems as well, right? So a lot of the same considerations of balancing load. And what you were saying about having many small messages is a little bit like what Rita was saying in her previous talk, in that you don't want to have big outliers that are going to take a long time to process, right? Yeah.
Absolutely.
Cool. Theo, sounds like you got something.
Sure. We have a lot of the same considerations at Circonus. A lot of them are soft real-time constraints on, we have two data flow pipelines, one that goes to permanent storage and one that goes through streaming analytics system, because the temporal requirements of those are different. No one wants to get alerted on something that happened an hour ago, so if you do have like a disconnection from a remote satellite site and aren't feeding data, you want to see those data points eventually, but you probably don't want them in your real-time alerting pipeline, because of the soft real-time system. If it comes in late, it's worth less than it's not worthless, but it's worth less.
So you just filter them out before they even get in that pipeline?
What's that?
So stale events, you just filter them before they even get into the pipeline?
Correct, yeah. Okay. So as they aggregate into the system, we have one that is that can batch and queue and put back pressure downstream, and another one that drops old messages and subscribes kind of just a few seconds behind the tip of the pipeline.
I guess that has the nice property that if you have an outage, your real-time pipeline will come right back without having a catch-up. Yeah, nice.
Yeah, so rebuilding models online and reincorporating old data to update predictive models and things like that is obviously a challenge. But from the consulting side, in all of the past, I would say that the most interesting thing from a design perspective, especially if you're new to pipelines, is that you probably don't really incorporate any requirements into them, and you just throw them out there and you hope that they work. And that is, I don't know, anybody not do that? It really is the case that people just say, oh, everybody uses Kafka, so I'm just going to jam junk in the front and hope to pull it out the back and everything will be great. I think the most important part of that is to focus on the operability of the system so that when it goes off the rails, you have the tooling and the expertise to be able to kind of wedge those things. Data shape is a great example of that. We had in our system, most of our messages range from, on the low end, about 80 bytes, and on the upper end, about maybe 128K. We had someone jamming 20 megabyte individual messages in to the system, and because we can't lose data, it stopped, and then it didn't go in, so they took it and put it in again, and it didn't go in, and it basically wedged the entire pipeline. And the key there is that, yeah, that's going to happen eventually. It's how do you triage that? It's like, what is the tooling and the operational mechanics in your organization around dissecting those problems and being able to prevent them?
Yeah, I mean, observability for your pipelines, and especially what's going into them, is huge. Yeah. Narayan or Rita? Yeah.
So one thing we haven't talked about so far is a subject near and dear to my heart, which is making sure that you have the right amount of capacity for the pipelines, right? So it is unpredictable how much capacity you need for a given job, depending on how the code changes and how the data changes, right? So the data shape changes. You suddenly start getting 20 meg messages, which seems to have probably happened to everyone here at some point or another. And you need good tooling to really help you understand how your resource consumption changes over time and which parts of the pipeline are consuming resources and how much. Particularly because, you know, as these systems get more and more important, you need SLOs, like Rita said, right? And so if you need your results in 18 hours, you need to have enough resources to be able to get the job done in 18 hours, and that's a huge challenge.
In terms of operability, something that I observed when I was running pipelines is that it's actually very important to have something that can scale up and scale down different jobs in your pipeline automatically based on what's required at the time, because you can kind of get this sort of bolus, like a big lump of stuff going through your pipeline, and each job needs to kind of scale up and scale down in turn. And that's terrible to manage as a human, but if you have the right tooling, your systems can do that pretty efficiently.
So I would say it's good and bad, right? It's good from the perspective that it reduces toil. It's bad from the perspective that people stop paying attention to it.
Yeah.
And so autoscaling will frequently take you into a situation where you're consuming all the resources that you legitimately have access to and a bunch that you are getting on sort of a best effort basis, and everything's cool as long as nobody else is using the resources they've got allocated, and then suddenly things get busy and everything gets slow and you're sad,
boxed into a corner at that point.
Yeah, and so it's I think that one of the real dangers of these systems that do things smartly is that you still do need to pay attention to them.
Cool. Rita, have you got anything?
Yeah, so I think in terms of consulting, what we've tried to focus on is like being sure we ask like, what is your SLO? Kind of like, what do the users actually care about? Because this impacts like what technology you might choose. And we also want to be involved in the choice of technology, because this is something that is harder to change once you've already written it. Did you choose a pipeline technology that has good tools? Then you don't have to write tools later on or migrate to one that has a better thing. Did you choose a storage system that supports your load and will scale to your load of like what you finally expect to have, which I guess ties into the resources. And yeah, I think that's the main thing.
And a little bit like Matthew was saying, many of these considerations are the same as a regular serving system. Yeah. Like it doesn't go out the door just because it's a pipeline. Cool. I think that's probably all for this question if none of you guys have. Cool. Okay. Scaling. What is your biggest challenge when scaling? I mean, all of you guys folks run absolutely enormous pipelines. So what have you grappled with and how have you done it? Or was it easy?
All the Google employees just say, I just use all the available resources, right? It's great. I say that there are kind of two challenges that we had when scaling the pipeline. One of them is scaling for expected growth, and the other is scaling for unexpected or hostile or Byzantine growth. And I think that the approaches to those two things are radically different, right? So one of the big challenges that we had is that we were trying to migrate into the cloud because we heard that it's wet and high up and clouds are great. So we were in a data center and everything's connected with 40 gigabit or 100 gigabit networking. You've got these fast boxes, they're crazy. They're like 3 gigahertz processors and RAM, and they cost like $2,000. That's it, and they last for 3 years, so they're basically free, right? And then I have 100 gigabit network between them with LACP failover, and it's effectively a sunk cost. It's free. I mean, it cost me like $50 a month, $60 a month to process 10 million messages a second. Then I go to Google, and the idea of using PubSub at that rate is insane. Like the cost has 4 more zeros on it effectively. And even to do the site-to-site availability requirements to move traffic from one availability zone to another, the bill is just like, it's like a power meter. You can just see the money disappearing. So it was incredibly interesting challenge to have to adopt the constraints of the general purpose system of a cloud provider to do something that was highly cost optimized. So that was a really interesting challenge. We did a lot of work on that. We changed the way our data flowed to make that work. And that's sort of related to the Byzantine scaling issue, is that you're going to get like huge bursts in traffic, and they're usually bad actors, whether it's a mistake in code or a client that just doesn't understand how things work and they do something really abusive. The ability to divert types of traffic that's rather arbitrary. So if you think, oh, I'll just do it by account or by user ID, that's not always going to work, right? So sometimes we have a specific tool that someone publishes that's really abusive, and now it's like 30 or 40 or 100 accounts start to use this tool, and we need to be able to block by a different signature or reroute. So the ability to kind of pick any point in that data pipeline and divert traffic with certain signatures and classification off into like canary pipelines, for example, to be able to deploy it in different ways, allows you to not burn the entire building down and just burn like a hut down.
Yeah, I've sort of referred to that concept as a sin bin. So that's really interesting. So you're almost sort of building in a custom pipeline anti-DDoS protection into your systems, right?
Yeah. I think it's required. Yeah.
No, I really want to chime in around these questions around network constraints. Is something we've really begun thinking about a lot. In general, we historically thought of, network is the free resource, it's infinite, it's out there, and boy, that's really not true. Network ends up being the major constrained resource for us in our data pipelines. And really small fluctuations in network latency end up having significant effects. So when we added, for example, a new data center that had a fraction of a millisecond additional latency at the volumes we were seeing, that really had an appreciable impact on our system. Another interesting way that scale has impacted network and the performance of our data pipelines is around data retention. So when you have a data pipeline, sort of the natural instinct is to say, okay, I want to retain 24 hours of data in this pipeline, because that way, if something falls behind or if I've made a mistake, great, the data is there, I have plenty of time to reprocess it at my leisure. The problem is with replication within the pipeline, if you're keeping around 24 hours, which in our case is multiple terabytes of data, and you have a node fail, all of a sudden you have this tsunami of data that has to be replicated across the network to other regions or other hosts within the pipeline, and you're crushing your network just with the internals of the data pipeline itself. So finding the right balance between replication duration and safety is really a key thing for us. And for us, a pretty key piece of tooling is the ability to increase retention very quickly. So normally we retain as little data as possible in our pipelines, but we have mechanisms so that if something goes sideways, we can bump up that retention in a really aggressive way.
So you just sort of keep older data around for serving purposes while your pipeline catches up in the background. Okay.
Yeah, a funny war story about that. Before we migrated to Google, the first Google service we actually used while we weren't in Google Cloud was the nearline storage. And so we retain all the data that comes into the system. So we have it for like 10 years now of data. And we had a compiler bug that optimized floating point math incorrectly and caused us to calculate standard deviation rollups wrong for 18 months before a customer actually called it out. And when we look back at where it was introduced, we had to nearline 18 months of data and reprocess it through the entire system. So it was awesome.
Sounds awesome.
Yeah, backing up output from a large pipeline can also be an interesting exercise if that's anything that anybody does. I used to work on a system that did that, and if you fell behind doing your backups, you could be maxing out tape drives for the week.
So one of the scaling issues that we run into is specifically around this sort of decomposed model where we're providing a serverless data analytics platform to customers who send us code. Then we run those pipelines for them. And this is a little bit different from the commercial pipelines that folks are talking about, in that we don't actually know what the pipelines do. We don't know what they're supposed to do. We don't know how they're supposed to perform. And we can't distinguish between performance problems, the notion of a performance problem for us is sort of poorly constructed because it might just be that the pipeline got more expensive, right? We don't even have a reliable signal for this pipeline is a new instance of this previous, it's another execution of the same basic code as this other run we've seen. And so what we're trying to do to debug those issues, effectively when you're trying to build a product around this stuff, you need to be able to tell the difference between things that are problems that you're causing and things that are intended behavior of the system by someone else. And so we're starting to build statistical models around correlation of lots of pipelines to see if all the pipelines are getting slower, then we know that it's our problem, right? If only particular users' pipelines are getting slower, then maybe that's a library that they're pulling in, or maybe it's something having to do with their data or workload, or that the performance is changing, right? Like getting slower is again, not a really well-formed concept. But performance overall, I think, is a really big challenge, even when you do know the end-to-end pipeline, right?
So it's hard to have the signal from pipelines when you don't understand their internal logic. Yeah, okay, thank you. Do you have anything? Rita? I know you spoke about, we didn't really talk about anti-patterns. I know you spoke about an anti-pattern before of having, large straggling tasks and those being slow. Have you come across any other ones?
Sorry, what was the last part of that?
Any other anti-patterns apart from having outsized tasks that take hours while everything else is done in 10 minutes? Any other anti-patterns that you'd like to talk about?
Oh, let's see. So,
or scaling challenges that you've run across?
Yeah, I think the workload issue is really important, and I think it was touched on. Yeah, that once you have more and more data, those long tasks or big tasks can get even bigger and take even longer. And if those are the things that are the bottleneck of your pipeline, then that, however long the longest one to process, is really affecting your bottom line. The other thing that I thought of when you were talking about backups was that as you get more and more data, even uncommon tasks like restoring all of the data, if something like catastrophic were to go wrong, will take much, much longer. So it might keep you up at night to think like, well, if we lost all the data, how long would it take before it was all restored and the users saw everything again?
Yeah, and sometimes just thinking about the computing resources it would take to either restore it or reprocess it.
How expensive, and also if you have to delete the data, there's a huge don't forget about how expensive your deletions can be. Maybe you might have optimized your data storage format for reads, but then you need to introduce a deletion pipeline, maybe for GDPR or something, and then you're getting all of this extra.
Yeah, GDPR is a huge can of worms for these kinds of systems that produce any sort of aggregated or sort of diced results. Yeah. Okay.
Yeah, I think from the anti-pattern perspective, the thing that surprised me most working with data pipelines is my background is scaling online transactional systems. Right, so building very, very large web load balancers, that sort of thing. And it turns out because almost all of the traffic generated against traditional transactional systems are user-based transactions, when you don't serve them, they go away, and they don't repeat themselves typically, right? So there's the rage clicking that happens, but it tends that if you have an 8-hour outage, it's not like you're going to have twice the traffic tomorrow. You're just going to have 5% more, or unfortunately 10% less. But in data pipelines, when you scale them, you have this kind of brutal truth that for every minute you're down, you're accumulating the volume, because the vast majority of data ingest into the pipelines, if you're outside of ad tech, is machine-generated data. And it's machine-generated data. It's still generating when you're not listening. So as soon as you come back online, the idea of scaling out to increase to accommodate increased demand, you start behind, and it's sometimes very difficult to catch up there. I mean, we've sit in our system early on, maybe in like 2012. We had a new customer that just unexpectedly ramped up very, very fast, and there was this thing where it's like, we're 15 minutes behind. And it's like, they're like, oh, that's not so bad. It's like, no, we're 15 minutes behind, and a half an hour ago, we were 0 minutes behind. That trend is a very bad trend, right?
That trend is infinity.
Every half an hour, we're gonna fall further and further behind, and adding capacity, like if anybody's added to Cassandra, for example, like the capacity planning required to accommodate cluster expansion and resizing takes a toll. So in the efforts of increasing capacity, you further slow down and worsen the problem. So the mechanics and the operations of those systems, they really, they have different consequences. So you have to be much more comfortable with how you increase capacity and what the ramifications of that are.
I will say though, even in systems where the events are human generated, just because your pipeline is down doesn't mean that the serving system that generates the input to your pipeline is down also. So you can absolutely still have those kinds of outages where the stuff just keeps coming and you drown. Okay. Anyone else got anything on this topic, or should we move on?
I guess I'll maybe just reiterate the point I made earlier around workload distribution, that in general, when you're building data pipelines, you're facing more or less the same set of questions that you would when you were sharding any other system. For example, sharding a database and making sure that, if you have to shard, which hopefully you expend the effort so you don't have to, you're at least sharding on a key that's sufficiently granular that you're not boxing yourself into a constraint where one pipeline is going to get extraordinarily hot or one partition of your pipeline is going to get extraordinarily hot.
Yeah, absolutely, hotspotting is still a thing. I mean, which depends on your design. So, okay, I think we're probably done with this topic. Catch up. I think we may have kind of already addressed this, but as you say, the input just keeps coming and you got to catch up. So we've mentioned already sometimes, you just need to find some more resources and add them, or else, in your case, maybe you need to find the abusive traffic and somehow isolate that away. Are there other strategies or things that people would like to say about catch up after an outage or after a slowdown?
I guess a couple of things. So first of all, in a way, this is a good problem to have. So if we rewind 4+ years at New Relic, we would have incidents where sometimes we would actually lose data. And we really don't talk about data loss anymore. Now we'll talk about data lag. Okay, our UI is 5 minutes behind real time. So it's a much better conversation to be having to start with. So one strategy that we've looked at using, particularly around our edge ingest, is the notion of a dead letter queue, that if downstream consumers of the pipeline are offline, we'll shunt messages essentially into this dead letter queue. And when the consumers of the pipeline come back online, we'll actually start by processing the real-time edge, because that tends to be what's most important to customers. And then after that, one can go back to a dead letter queue and say, okay, well, we'll devote resources to backfill in parallel with catching up with the live edge of data.
I think that's one of those things that harks back to the first question about system design. I mean, whether or not that makes sense for your system is very dependent on what kind of data you have and what the use case is. But it's absolutely a strategy. If the most recent data is most important, process that first.
Yeah, FIFO is not always really the answer.
Yeah, so I mean, we actually have two data ingest pipelines. So one that is always temporally relevant and one that is always important, right? So it's effectively like that. It's just that they're kind of separated at the generation source. But your comment that it's always a good problem to have, in business it is, I agree with you. But there are a lot of data pipelines where people are doing internal things where they don't have cross-organizational billing for that. And some of these problems are really, really hard to have because you have someone who is not generating high value over the damage that they're doing, right? And so you have one person who has a small workload that is suffering at the hands of someone who's just being an idiot and saturating the resources. And those can be really challenging problems to deal with. It's a lot easier in business because, I'm brutally honest, every company, every customer has value, and you try to isolate them in buckets so that if one of them is compromised, or slow, not compromised, but slow, that they're uniquely affected as a customer and not that.
So I can think of two techniques or design patterns we might use to address this. If you have, so say you have a batch pipeline and it depends on the nature of the outage, but let's say you have a batch pipeline and the outage just caused your pipeline to keel over and it was like 95% done. And then it comes back online, but it needs to start all the way from the beginning, and it's a pipeline that takes 8 hours to complete. That's gonna hurt if you need it to be done soon. And if this had been a streaming pipeline, outputting input, outputting data continuously, or you had somehow otherwise implemented some checkpointing, you could pick up right where you left off, and then you only still have to process that last 5%. Another one I think is multi-homing of pipelines. So if the outage is just to a particular region, if you can fail over to another region, ideally say, similarly, just processing right where you left off, that can make you withstand regional outages. So I know those aren't all of the different types of outages, and whatever pipeline you're on may not be instrumented for multi-homing or mastership election yet, but that could be, if you're worried about this, choosing a pipeline technology that allows you to do that, or starting with streaming instead of starting with batch could help.
I want to second the multi-homing thing. So as I said in the beginning, the network was free when we were in a data center. We're close enough because I can get a terabit between cabinets for cheap. But between regions and Google is really expensive. So we actually multi-home from the customer into Google because that bandwidth's free. So we just changed the way the pipeline worked. And by multi-homing into 2 different regions, the ingress traffic ends up being double for the customer, which is outbound, but it's a small for individual customers. And then it ends up being twice as much on Google's egress points, which they don't seem to care about. And it worked really, really well for us.
So going back to Theo's earlier point about isolation between customers, which I think is if it's not already a subject near and dear to your heart as SREs, it should be. Having QoS that's pervasive throughout your system is so valuable for this. And it's not a thing that exists in sufficient form yet, I think, broadly, but is a very good thing to focus on as you build your infrastructure out. Figure out ways that you can implement classes of service and start tagging your workloads so that your infrastructure can tell when you need to shed load, which load should you shed.
Yeah, I think when your infrastructure gets to the point where you don't know all of the people who are using it by name, you need to think about QoS. Yeah. Okay. Anything else on catch-up? Great. Cloud. We talked a little bit about cloud. So Theo, you spoke a little bit about your migration experience to cloud, and Narayan, you run this stuff. Is there anything further that you guys would like to say about the suitability of running your pipelines in cloud? It seems like it can be a very expensive proposition. Are there ways and means around that?
So I feel like I need to defend our pricing policies, but I'm frankly not equipped to do that. But I think that it is very hard to compete with completely bespoke pipelines, right? So when you're building a particular piece of code that is well tailored to the environment that you're running it in, you can make it incredibly, incredibly efficient, right? And all you need to do is keep running that environment in perpetuity. Just that easy, yep. Right? And so this is sort of a mixed blessing, right? Like, sometimes it's the right thing to do, sometimes it's not the right thing to do. What I can say, broadly is, like we would have these conversations, 10 years ago, but definitely 5 years ago, that like, is the cloud ready for intensive workloads of a variety of sources? And I think at this point it's solidly there, right? The performance is comparable. You're getting all sorts of managed offerings that manage open source software, you're getting customized stuff. I mean, the real question is, when do you end up in this place where you do something that is incredibly well optimized and custom versus not? I think that's really what this question boils down to. And I would say that for most use cases, you probably don't need to do that at this point, but that's my take.
Yeah, I mean, if you're running a smaller pipeline, you can pay the money and get the reliability for, as part of that. If your volume is higher, you need to be more thoughtful. I mean, as Theo has pointed out a couple of times, a pipeline is fundamentally shipping a bunch of data from possibly everywhere in the globe into 1 or 2 locations for processing, and then potentially shipping some of it back to the customers. So it's very network heavy. So I think being thoughtful about your network as a resource is a big deal.
Stepping aside from sort of the economic side of it for a moment, one of the interesting things we've thought about is, both in many cases in the public cloud and in many multi-tenant environments, there's much more variation in the resources of the systems that are consuming out of pipelines. So in a data center, you can be reasonably sure that, okay, if I provision 10 workers to be consumers, they're all the same type of box, each of those boxes is going to be able to process X messages a second. And that becomes much less true if you're running in an environment where there may be CPU steal, there may be more network contention from other other tenants on the same infrastructure. So that can cause you to rethink some of the fundamental assumptions about how workload is allocated. And I do want to put in a plug here, actually, for a talk that my colleague Andrew Bloomgarden is giving tomorrow on the Nth Region project, which is around containerizing and spinning up an entire new region and logical instance of New Relic, which touches on some of these questions. So encourage everyone to attend that. Okay. Anyone else?
I would say that the most surprising thing, just from a personal perspective in the cloud, every time you do something, you're like, I didn't see that coming. So we were able to re-architect our data ingestion pipeline. It took, like 2 days behind a whiteboard, and then like a couple of days of coding, and then 6 months of getting customers to actually deploy the new code, because it was on the broker that the customers run. But once we got that going, that changed the pricing dynamics of all of that stuff except for one thing, which is we've run from day one. And, when we launched the company in 2010, we were in 2 different data centers on 2 different networks in 2 different states. So we could, my biggest concern from a business perspective is that somebody doesn't pay their bill on time, not pay us. We don't pay our bill on time, and somebody shuts off the service, or there's an accounting mistake, or someone sends a cease and desist letter, or something like that, and then your data center just turns the switch off, and then like, what do you do? So being in 2 regions with Google is always a risk that Google can still turn the switch off, and that concerns me a lot. But when we designed to be in 2 data centers, we had a dedicated circuit between them, but we would constantly, every single week, we would fail nodes. I mean, Chaos Monkey was basically, since 2010, you blow a node away and rebuild it every week. Make sure that works. There's now an OpEx cost that is real, and every time I do that, because of the inter-zone, the inter-region transfer costs. That was never there before. So now, like, every time somebody says, I want to make sure my software works, let's kill this node, it's like $600. And it's like, boom, like that, just to pull over, 8 terabytes of data across the network. So that was really surprising, and I still haven't swallowed that. I'm still a little resentful about that. Little.
I'm sorry you're sad about your $600. I'll buy you a beer after this.
I still don't regret our move to the cloud. The move to the cloud was good. There's just certain things that surprised me that I'm still uncomfortable with.
Okay, we're going to talk about this extremely briefly, and then I'll take audience questions. So we've talked about streaming versus periodic or batch, as you were referring to them, pipelines. Why would you pick, are there still reasons why you would build a batch pipeline? Why would you switch a batch pipeline to streaming or vice versa? Is there any reason in the modern age to build a batch pipeline?
Absolutely.
Great.
Sure. Okay,
So yes, there is absolutely a reason to still build a batch pipeline, and the reason is, generally speaking, performance, right? So if you don't require quick access to the results of the analysis, so you can wait a little while to batch your data up before doing the analysis, you can get, generally speaking, a lot better resource utilization and a lot lower computing costs. And that's a very legitimate motivation to want to use batch, right? There are a lot of benefits for streaming as well, and it really depends on exactly what the consumption patterns for the data that you're generating are. So, I mean, I guess this is a little bit of a plug, but the SDK for one of the products that I work on, Cloud Data Flow, is Apache Beam, which is a multi-backend unified batch and streaming programming model. So you can implement it once and then execute in lots of different places on Dataflow, but also on Flink and on Spark. And this kind of an approach, I think, in the long run is going to be pretty good, because it allows you to make this, you implement your pipeline once, and you can sort of move from executor to executor and between batch and streaming without really making too substantial changes. But absolutely, we still need both. And I think we're still a little ways away from being able to go streaming on everything.
Cool. Actually, another interesting use case that I've seen for a batch pipeline is actually to check the correctness of your streaming pipeline at intervals. And you spoke about using, Rita, you spoke about using golden data, input data, as like a probe through your system to check correctness. And but having a backup kind of occasionally running batch pipeline is something I've seen as well. So that's another reason. Anyone got anything else before we take some audience questions?
I guess two very quick things. One is that batch pipelines can offer more malleability if the shape of the query or the shape of the processing is going to change frequently. The cost of deploying new code to run a new type of transformation on a data set tends to be significantly lower. So if you're not quite sure what you're doing with the data, batch offers some advantage there. The other is that in some cases, this is I think what you were referring to, Narayan, is you end up needing to retain state actually a lot less in batch systems. So if, for example, you're doing aggregation over an hour-long period of messages, either you're going to end up with a streaming pipeline with lots of bits of intermediate state as you save those checkpoints out, which gets computationally expensive, or you have a batch pipeline where state is actually retained for a much shorter period of time while the job is running.
And against that, we have a lower latency to get your output from a streaming pipeline. And as Rita said earlier, also, if your pipeline falls over, you don't have to reprocess everything that it had already processed. So.
I mean, there's two fundamental things. In a streaming pipeline, it assumes that your question is only valid going forward, which is dumb, right? I mean, like, if I have a new question that's interesting, it was probably interesting last month too. So I need to be able to ask it on historic data. And most of the time, it's much more efficient to ask that in batch on historic data than to restream it all. That's insane, right? So that's one. And then the other is that there are online algorithms and then there are non-online algorithms. And if you have a non-online algorithm, you can't put it through a streaming system. That's just, at least until there's new computer science, that's not possible. So if you only do streaming systems, you eliminate an entire class of algorithm application to your problems.
Very true.
I feel like I need to throw in one more advocating for streaming pipelines. I don't know. As long-lived jobs, they're a lot more like serving jobs. I think they're arguably more manageable and easier to debug.
Yeah,
because you can see them, you can see it as it's happening. It doesn't like just go down and then you have to run it again, and hopefully the same thing happens.
And your systems haven't eaten all your logs because new jobs are running on the machines.
Yeah, I know I much prefer to be on call for our streaming systems than the periodic ones.
Yeah, I feel the same way. One thing in favor of batch maybe is that if you do need to fail over because something falls over, there's a lot fewer moving pieces in moving a batch job to run somewhere else, spinning it up, as opposed to trying to sort of shift a streaming pipeline, unless your pipeline has been well designed to support that.
Yeah, I wanted to caveat everything I've said with the type of data that we do. So you were talking about hours-long batch, like 8-hour-long batch jobs. Our streaming batch jobs are usually around 10 microseconds or shorter, and our batch jobs can range up to a whole like 2 seconds. So the debugging stuff changes a lot when you have an iterative cycle for a human that's only I mean, in the worst case scenario, maybe 10, 15 seconds, but we don't have any really long batch jobs. If I need to go read 7 years of data and reanalyze it, it still only takes, a couple hundred milliseconds.
Theo's computers are faster than everyone else's.
No, I have carefully selected a very small scope because it's comfortable.
Okay, have we got we've got time for like 1 or 2 questions from the audience. Okay. Thank you, Greg. I'm going to give the mic to the people who know stuff.
I have a question about environment in which Narayan described when you operate multiple pipelines. You don't control the code, and related unpredictability of the performance. Understand the pipeline can suddenly start running for multiple times of the average runtime. Do you have any experience or insight with distilling a useful monitoring signal for that and communicating it to the users? Do you expect them to declare some sort of the intent about expectations of the behavior?
So this is really complicated because expectations tend to vary really widely. So your second question is complicated. I'll answer the first question first. So the thing that helps us to get a good handle on what's going on is a generous amount of performance instrumentation. So we can tell when a pipeline is going slowly compared to another pipeline, which are the stages that are going slowly and why. Right? So if, for example, we find out that a pipeline is going slowly because it's this particular stage, and it's because it's doing I/O at either a different volume or a different rate than usual, then that actually gives you a very good sense of what's going on. And that's a really useful thing to be able to tell the customer, even if you don't know if this is intended or not. Right? And so really the only, there's no shortcut. The only answer to understanding performance problems is having really good performance instrumentation, and then having the mechanism that you can use to derive a baseline from something, right? So what's a previous run or 10 previous runs, and get a sense from that. But this is a complicated sort of endeavor. For the second question, I think that we're really too immature around SLOs for pipelines in particular at this point. I think the language is starting to develop and standardize. I mean, Rita went through a bunch of great examples in her talk. We're starting to get to the point that I think everyone is converging on the notion of how much data you've processed, and if you processed it all, and what's the latency with which you've processed it, and things like that. But this is not a thing that I think. There's this phrase that we use at Google about SLOs, where if you don't create an SLO for something, your customers will make one for you. And I think that that's really what you're talking about here, right? So you have if you're running a service for a bunch of users, they have their own expectations, because that's what the brain does. It creates expectations about the world. And so they've run a pipeline a bunch of times, and they don't know that they were running during a holiday break when nobody else was running, and so their jobs are running twice as fast as usual, or the baseline that they're deriving intuitively isn't the right, isn't a deeply true one, right? And I don't know if there's a good solution for that aside from getting people to start really looking at the data more and making, quantifying their expectations and quantifying performance and really starting to have a discussion about that as opposed to these sort of intuitive notions that we tend to.
We have a much more constrained version of this problem at New Relic, since our pipelines are just used internally. But we have a lag monitoring system that's offered by the pipeline team as part of the pipeline as a service that essentially looks at the difference between append time and when a message was consumed and committed. And this is just available then for users of the pipeline to configure an alert and say, okay, this much lag is acceptable, this much lag I should be alerted. So that's kind of one way of helping define those expectations. And then within the pipeline team, this is sort of what you were gesturing at earlier. There's if we see lag across multiple pipelines, we can say that's probably an issue with the infrastructure. If we see lag in a single pipeline, we say that's probably an issue with the job that's being run against the data.
As a plug for an open source tool, we don't actually run Kafka, but we have a whole bunch of customers that do, and we have a TCP PCAP analyzer that will measure exactly that. It measures ingestion time. You can break it out by topic, and delivery time to the client. So you can see how many nanoseconds, or more realistically milliseconds, a message stays in queue through your Kafka cluster. It's open source. It just kind of dumps the metrics out.
One final question. All right. Thanks for a super interesting panel discussion so far. I have a question mostly related to streaming, but possibly also might be related to periodic pipelines. And you guys have mentioned that partitioning and bad partitioning and sharding could be an issue. And that sort of assumes that there's a strict order of processing things, so we haven't talked too much about ordering of things. I'm a bit curious, I guess it's kind of a quite open question, but to what extent do you think, should you spend time on making sure you can handle things in an unordered fashion to avoid having partitioning issues, essentially? So that's my question to you. Thanks.
So I think that we tend to think about partitioning and ordering as somewhat different problem domains. Partitioning is more about how we allocate workload across the set of consumers that will be reading data out of a pipeline and doing something with the data. So is that randomly distributed? Is it distributed by some attribute of the data, et cetera? In terms of ordering, the systems that we use tend to be loosely ordered, and fortunately for our use case, we usually don't care about order that specifically. We care about order within approximate time ranges rather than down to the microsecond. So our general strategy tends to be data will collect in an in-memory buffer for some period of time until we can be reasonably sure that, okay, we're now getting older messages. And there's some fuzzy logic entailed there. It's a trade-off between essentially, latency that you're deliberately introducing into the system to correct for out of order versus throughput rate in the overall pipeline.
Yeah, I mean, our problem, probably very similar. We have certain mathematical operations that require continuously time progressing, like monotonically time increasing things, like differentiation or integration or things like that you would do on the signal. And those, we do the same thing. We have I think it's a 1 second buffer where anything inside there, we assume we have all the milliseconds once we've seen the next second. The interesting part of out of order tends to not, we don't tend to see many problems in that area. Things tend to come in order from customers unless they come really out of order. Like, that's from March. Like, what happened? So we'll have a customer that's been collecting data and their broker turns off and then suddenly it comes back on and you get 6 months of old data. And the really interesting dynamics there are the streaming versus batch pipelining stuff, because a lot of the reporting and visualization for historic data that you would do would go off of a data store that has that data in it, but the alerting and analysis that you've produced off the streaming pipeline, of course, did not have that data in it. So you have a reconciliation problem for users where you say, what is my total bandwidth between these two data centers? And they say, well, you never alerted me that it went over a gigabit, and it went over a gigabit. And it's like, well, you only reported one data center for the 6 hours, and then the other data center came online and backloaded, and there was no way we could have known during that time that they added up to more. And I think that actually, when I said it was complicated, that's a product problem and not a technology problem. Like, it's about setting user expectations for what happens.
This again is that these sorts of things are exactly the considerations that you should be thinking about early on in your system, because, I think it was Matthew was talking about as a means of recovery, whatever things are sending data into your pipeline. At some point, your pipeline ingestion may go down temporarily, or the network may have a hiccup. You've got to be able to spool your pipeline input, your ingestion events, somewhere near where they're produced. So that means logically, at some point, you're going to have one of these boluses of old data come because one of these things gets connected back to the network. Yeah. So you got to think about what's right for your system when you're designing it.
I just wanted to tie the out-of-order bit into an SLO can help you manage this trade-off as well. So knowing exactly how you bucket might be hard to get. When are you going to get the out-of-order data? But if you have an SLO that tracks how many of these out-of-order, measures how many of the out-of-order responses you get, you can, if you're finding you get too much of that, then you spend more time on that part of the system.
Okay, thank you all so much. I'm afraid that we're now well into the coffee break, so you should all probably go and drink some coffee. So I would like to thank all of our lovely panelists.